Hello, this is Ms. DB, and we are going to explore what elements need to be congruent in order to have congruent triangles. So it says to choose 3 elements to make a triangle. So we have to choose 3 things, like we can say a side AB with a given side angle A, and then let me choose side AC. So A and A need to connect with this vertex A. So you're going to you can pick it up by picking in the middle, clicking and dragging. And I'll drag A to A, and then swing B around so that it matches up with the ray on the angle. And then the same thing over here. We got to pick this up so that A goes on top of A, and then swing C so that it lines up with the ray. Then a triangle will be created. Now your job at this website is to see if you can make another triangle that doesn't look exactly the same as triangle ABC. If you can make a triangle that's not exactly the same, then side, angle, side is not enough to show that you have congruent triangles. So let's see. Here's side, or J, angle J, so we need to put this J on top of that J. So we drag it. Now, if the only triangle that I can make is exactly the same, if I try and again and I can only make the exact same triangle, then I've shown that, at least for all the example I've done, that side, angle, side seems to demand that we have congruent triangles. I'm trying to line these up on top of each other, and it didn't flip very much. Let me flip this one. Now, I think that they are... Oh, maybe I can drag by like this. There we go. I can drag. So you can spin it around. And now I need to flip it again. And then put it right on top of each other. If they look exactly the same, then they're congruent. If all the angles are congruent and all the side lengths are the same, then they're congruent triangles. Correct. Now they're going to ask me to try one more time. Is it possible to make a triangle that is not congruent to a triangle ABC? So I'm going to try one more time, and I'm going to try as hard as I can to make one that's different. The thing is that I picked that the sides were going to be the same length, right? And I picked that the angle in between the two sides were going to be given. So that's the only way I can do it. Watch what happens if I accidentally put M on top of L instead of L on top of L. You won't be able to make a triangle. I'm like, well, what's wrong? I put it right on top of it. Why doesn't a triangle turn up? It's because you have it facing the wrong way. So we have to spin it around and put L on top of L, and then line this up. Okay, there's another triangle. Let's drag this over here and see if it's exactly the same. Put it on top of the pink one, I guess, first, which I already showed was the same as the blue one. See, it's exactly the same. These triangles are congruent. Now you can keep trying, but every triangle that you do is going to be congruent to the 2 triangles I already have here, now the 3 triangles. So that shows that side, angle, side is enough to show that you have 2 triangles that are congruent to each other. Now you can change these. You can do it with side, side, side. That's one that we're going to explore in this chapter. You can do it with, try it with side, angle, or angle, angle, side, and see if that works. You can try it with, let's see, angle, side, angle, see if that works. For your journal, you're going to explore angle, angle, angle. When you have just angles, you can move them wherever you want on your, and you just drag the end of it to match it up. And then B has to go over here and swing that around. And then you'll, these are a little tricky, these angle, angle, angle ones, because there's no side lengths to determine exactly where this goes. But you can, if you mess with this enough, you will get a triangle. I think I have to move this slightly this way. So you're not done manipulating it until a triangle pops up, a solid shaped triangle. If you can manage that, you've got it made. Angle, 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 for some reason, I think it's because there's no sides on here, is a tricky one to make it be a triangle. Maybe I'll try it closer together and see if that eliminates some of my swinging around. See, it's so close. There, finally, gosh. Now I'm going to try another triangle. And your second triangle, again, you get to determine where the vertices, how far away they are from each other. So you keep manipulating this and you see if you can make another triangle that is not congruent to the first. If you make two triangles, if they both pop up triangle and they all had the same angle, then that will not be enough to show that you have congruent triangles. And then in your journal, there's another one you're going to do, which is side-side angle. So let's see, side. Yeah, turn these off first. Side, side, and an angle not in between them. And you'll try it with that one too and see if that's enough to prove triangle congruence. So anyway, this is kind of a nice tool to show kind of informally which ones of these elements, or which three, are enough to show that you have two congruent triangles. All right, thanks a lot and have fun playing with this little application.